I'm Phil Bullinger, Senior Vice President and General Manager for the Data Center Business Unit. You've seen presentations covering client and mobile activity. Now we're going to switch gears and talk about data at scale and really the dilemma that the industry and the world faces today when it thinks about data at scale. We will be making some forward-looking comments, that's why you're here, right? But we are a public company, and just keep that in mind. In particular, we're in a quiet period right now ahead of earnings, so we're going to stick to products and technology for the most part right now. So there is really an opportunity and a dilemma when we start talking about data at scale. And some of these numbers are kind of hard to get your head wrapped around. Accenture did a study, and they published a report that said by 2030, the value of IoT data generated from endpoints in general, would be $3.6 trillion, trillion with a T. I read a quote recently, or I saw a quote recently that Bill Gates had made. He said, you know, we tend to always overestimate the amount of change that's going to happen in the next 2 years, but we always seem to underestimate the amount of change that's going to happen in 10 years. If we think about a 2030 timeframe, this really isn't that big of a leap, even though the number seems very large. But what this drives really is data has become the engine of the global economy. We used to think about data as maybe just an artifact of our digital lives, but if you really pause, you know, our jobs, our relationships, our health, even our security now fundamentally depend on data in many ways, right? And so this engine of the global economy has become an imperative for businesses, for consumers of the data. It's just an enormous opportunity going forward. But this also presents a dilemma, and this is the dilemma that data has not only become the engine of the global economy, it's become, for almost every business on the planet, probably the most important asset, certainly enterprises at scale, the most valuable intellectual property, the most important business asset, how businesses contend and deal and process and store and gain insight from and respond to data, in many ways has become almost an existential question. And so this notion of how efficiently and effectively enterprises deploy data, especially data infrastructure, often determines their success and even their longevity. Whether you're an automotive company, a pharmaceutical company, a consumer products company, a tech company like Western Digital, how you deal with data, how you effectively manage it, how efficiently you capture it, you transform it, you gain insights from it, really determines the longevity of your company at this point, irrespective of what actual business that you're in. So this notion of data infrastructure becomes very important. And I want to touch on this notion of efficiency, because efficiency is really measured in many ways by total cost of ownership. If you think about data centers and data center architectures, and I'm talking about data centers at scale all the way to what we consider to be edge data centers, within proximity perhaps of the endpoints that are generating the data that they're capturing and acting on. Data locality, latency, performance, those things define in many ways where you build your data center, but what the data center actually looks like inside is oftentimes most driven by total cost of ownership, the efficiency with which you're provisioning and platforming that data center infrastructure. And it's not just about equipment acquisition costs. We like to think about what is a service company, an enterprise have to pay for the assets, compute, networking, and storage. But it's a lot more than that. A lot of it has to do with density, right? The efficiency of the floor space that you have to work with. Power and cooling costs, of course, play a huge role over time. And installation and monitoring and maintenance. The purpose of this slide is really to start to frame the conversation around how we think about data infrastructure and the value proposition that we're providing to our customers. Capacity enterprise hard disk drives are the engine that's enabling data at scale in the world today. Exabyte shipment growth, you can see the curve here. Capacity enterprise drives today are the vast majority of how the world persistently stores data, Phil? And it's going to continue to be that way.
It's been like 3 years now. We've been talking about the end of disk and SSDs take over the world, QLC and 5LC and whatever the next number is going to create storage so cheap that disk will go away. Disk is not going away.
Disk is not going away.
During this whole environment here,
Yeah, and we Western Digital has probably the best possible perch in the industry to look at the trends, the cost dynamics, the customer adoption patterns, because we are heavily invested in both legs of the stool, transistor flash technology as well as rotating disk. And disk is not going away. In fact, the curves are accelerating. So the value proposition of capacity enterprise drives is compelling today, and it'll be compelling persistently into the future.
But is the role of the hard disk drive changing then? I mean, so the capacity we have today is around between 15 and 20
terabytes.
And terabytes.
Yeah.
And we are talking about 50 and maybe more in the future, but the technology is the same at the end of the day. So the number of IOPS you have is the same. So it is becoming colder storage somehow.
Well,
And the mechanical parts are the same.
Yeah, it's a really good point, Enrico. And as we proceed through the presentations, you're going to hear and see some information on how that technology curve is expanding. We recognize that IOPS density is an important characteristic, right? And as drives get larger, that becomes a greater and greater requirement, right, to solve that problem. We're not sitting still on that front. Assuming that a disk drive is going to be the same tomorrow as it is today, it's just more terabytes. That's not exactly the case, right? But yes, I think storage in general is, you'll see more and more tiers evolve. You'll see faster and faster and colder, and because companies, frankly, are getting better at monetizing particular SLAs of particular storage tiers, of particular media tiers. Capacity enterprise, we see going forward, and this graph illustrates that, and you can stretch this out into the future, really as far as your planning horizon to go. We expect to continue to be the engine of data at scale.
Okay, so I have another question.
Yeah.
Is it the capacity enterprise hard drive more an hyperscale kind of play in the long term, and we see more SSD in the smaller data centers? I mean, there's enterprise data center is not comparable to the hyperscaler data center where you have all these tiers and everything. And
it's a very good question. We think about customers in various segments: hyperscale cloud, system OEMs, second tier MSP, CSP providers, all the way down to mid-size and even small-size enterprises. You will find what would be generally defined as capacity enterprise drives in every tier, as well as SSD technology or flash components themselves. What you will see is when you get into the larger capacity drives, I would say above a 10 terabyte, 12, 14, I'll talk about our roadmap and what we're shipping today and sampling today. The software architecture changes on top of that. Once you get into the really larger capacities, you can't rely on a brittle RAID stack anymore to protect the data. You have to move to erasure coding techniques. You have to move to data protection architectures and more software-defined approaches that deal with larger capacity points as sort of the unit of storage. But the efficiencies that you reap from higher capacity drives are so compelling that the industry is rapidly moving that direction. And so it's actually becoming less and less the case that the typical storage stack is employing 25, 30-year-old RAID technology, and much more likely now to be deploying more modern, contemporary forms of data protection, which frankly are very oriented towards high capacity drives. So the reason the hyperscalers, we always think about high capacity and hyperscalers, they purchase a lot of them. That's where a lot of the data is parked, right? You guys know the data in the industry with infrastructure spend on-prem versus cloud. It's really tilted over, but it doesn't mean that you won't find that technology in every segment, both SSD and capacity.
Well,
also,
it's a long discussion, but
yeah.
Just because there is another problem, because you're talking about erasure coding, this kind of, so it's a lot of write amplification in the backend, and again, IOPS, and again, so you need complex architectures, and you have a lot of storage in the backend that is too much compared to the size of the, to the space consumption in the data center for a small organization that has a small data center. So the entry level becomes too high for these kind of guys. This is, you know.
We also, it is a longer discussion. I'd love to dig into that with you, but we also tend to think about capacity enterprise as only the highest capacity point. We always want to talk about what's the highest capacity point shipping in the market. The capacity enterprise market is a robust market that touches a number of capacity points. When we think about the capacity enterprise market, we don't think just about our 14 terabyte drive. We think 14, 12, 10, 8, 6, 4, 2. These are all high capacity drives that have a particular value prop and a particularly, an I/O density. And going forward, it's going to be a multi-flavor world going forward, just like it is today. So let me press forward, and then we can get into maybe more in the panel discussion. One of the reasons high capacity enterprise drives are the engine of data at scale is because of the value proposition that they bring from a cost of ownership point of view. If you think about a 14 terabyte drive versus, let's say, an 18 terabyte drive, which we're sampling now. It's the highest areal density drive today. We're very excited about this platform, but just thinking about the impact in a data center. And this isn't a large scale. I've got an example later of a large scale deployment of this. But just think about 4 U100 storage enclosures in several racks of storage. But if you fix the capacity, and you also fix the dollars per terabyte. In other words, if that 18 terabyte drive was the same dollars per terabyte acquisition cost of the 14 terabyte drive, there are some incredibly compelling economics still at work here from a density perspective. 22% fewer racks to hold the same amount of data. The idle power is essentially the same. The power per terabyte is dramatically lower, which is crucial. The baseline of this, if you add up all of the factors that we think about when we think about a TCO model for an at-scale data center, from acquisition costs, power and cooling, floor space, rack infrastructure, server, networking infrastructure, when you add all that up, even if you paid exactly the same dollars per terabyte, you'd be saving 11% in terms of your TCO. And that's why the industry is compelled, the customer side of this is compelled to move to these higher capacity drives because there's great value that's delivered. Now this equation is understood by our customers, and Western Digital we're working to kind of shift the narrative in the industry around high capacity drives from simply a race towards lower dollars per terabyte to a conversation around how these products, through innovation and capacity scaling, deliver greater value to our customers. It's a message that's resonating.
But still, it's the same question. How do you get the IOPS up? 14 terabytes versus 18 terabytes. Let's say it's 200 IOPS per second. I don't know what the number.
Well, there's going to be a point where multi-actuation is required, right? And you're going to have to. And there's. I'm not going to get into all the details, but and you got to think about more streams out of a drive in ways that are not just more actuators as well. So there's a lot of innovation and science and engineering that's going into improving the IOPS density of very large capacity drives. So you might lay awake at night worried about this problem. We do too, and we're solving.
I'm not worried about the problem.
So
I don't.
So helium is an important technology, and it's something that I think today the world takes for granted. Helium is 1/7 the density of air, which means when you hermetically seal a drive with helium, you reduce the power, you reduce the flutter, you increase areal density. There's benefit after benefit after benefit that goes with a helium drive. We invented this technology, we perfected it, and we're by far the leader in the industry on shipping helium drives. We've shipped 5 generations of Helium HDDs, more than 50 million cumulative units, over 540 exabytes shipped. We know how to hermetically seal and fill a drive with helium and extend its life cycle, reduce its power, improve its areal density. It's an important technology, but it's not the only technology. One of the things that we'll expand on in later presentations is this envelope of technology that goes into delivering higher capacity drives. It's not one answer. There's not one Hail Mary throw down the field that gives you, Shazam, a higher capacity drive. It's a collection of technologies. Helium plays a role, absolutely. We're moving into the energy assist era for high capacity drives. We are the first company to ship at scale commercially energy assist technology, and in the drives that we announced right before the holidays that we're sampling, our 16, 18, 20 terabyte platform is the very first drive with energy assist technologies. You'll hear more about that in a bit. But beyond that, there's an incredible amount of mechanical innovation that goes into a hard disk drive. We're talking about a mechanical head centering on track pitches that are measured in nanometers. Think about that for a little bit. That incredibly complex technology in the mechanical domain as well. SMR is also another initiative where we're shipping today to multiple customers shingled magnetic recording drives that overlap the tracks that get higher areal density, really built for sequentially written, read-intensive workloads. And a lot of the data that's being generated, towards that 103 zettabytes is sequentially written, read-intensive data streams from IoT sensors, from video cameras. Also, there's a lot of innovation going into the firmware side of our drives. Our drives are incredibly complex in the software domain as well. Advanced queue management, I mentioned dual actuator. We have technologies beyond that deliver both capacity and performance. We recognize both sides of that equation are important. And this is a proof point of this, right? We continue to invest significantly in hard disk drive technology. We have over 7,000 patents as a company now in this field. I just laid out a few examples of areas of technology that we have patents in. Helium, MAMR, microwave assist magnetic recording, HAMR, heat assist magnetic recording, micro actuation, which is the multiple stage actuation capability of our heads on top of the platter. You can see by, for example, the largest category here is HAMR. But we're not just betting on one technology. We're in pursuit of areal density expansion. We lead in areal density. We've led in areal density for many generations of drives, and we're pursuing multiple technologies to continue that path forward. And the science and the engineering that flows from that are reaping significant advances for us. And we're going to continue to invest in all of these. We don't think it's a one answer thing. We don't think one technology runs out of steam and then the other one takes over. We're pursuing both of these going forward with success.
My understanding, Phil, is you guys were focused on MAMR drives, right, for the next generation.
Well, we talked about MAMR, but you can see we've been investing significantly in HAMR all along as well. I mean, this didn't happen overnight. One of the things you're going to hear today in several ways is right technology at the right time, right? These technologies hold promise. Some are more applicable to today, some are more applicable to tomorrow with more science and engineering that needs to go into it. SMR I mentioned. I think everyone kind of probably understands SMR to some degree, the idea of overlapping the tracks, creating effectively a higher density layout of data on the disk. This isn't just about, it just looks like shingles on your roof. Yes, that's the way the data is laid out, but incredible amount of firmware and complexity associated with reading those things, how to go in and manage that, how to put the bits down in a way that you're not worried about adjacent track interference. We really believe in SMR technology. We think in general, data locality, data placement, how data is written to the platter is going to have as a big an impact going forward as other advances in engineering.
You think SMRs? Go ahead.
Why do you think that from 2020 to 2021 we will get all this bump in sales of SMR?
Because we have close relationships and technical interaction with our largest customers who are investing significantly in bringing SMR drives online. And so,
are they, again, hyperscalers or enterprise players? I mean, traditional vendors.
We have customers in both segments. Think about workloads and data center infrastructure that would benefit most from capacity increases, where a lot of the data is sequentially written and read intensive. And that'll point you towards the areas of the market that are adopting SMR technology. We have some great public examples of this. You can go on our website, but non-public, there's a significant amount of investment headed this direction.
But SMR has been around for 3 or 4 years now, right? I mean,
it takes time. It takes time.
Also, in at the end of 2019, I was briefed by all the object storage vendors. Nobody was working on SMR. And we're talking about like 15 vendors, all the vendors.
All the vendors.
So, again, I totally get that.
Object storage, right?
Object storage,
Yeah,
guys,
yeah.
that theoretically they buy,
Big
more-
amounts of storage.
Yeah. More,
Based on our knowledge as a company, we believe by 2024, almost half of the capacity exabytes shipped
Yeah.
are going to be SMR.
Okay.
Whoa.
I have to believe you. I mean,
You would know better than anybody,
Yeah.
right?
but anyway, I don't believe. Still, we don't see any adoption at the enterprise level. Maybe the service providers. Yes, cloud
Again,
providers.
a longer conversation. Think about the changes required in the application and operating system stack to take advantage of an SMR drive. It takes time, right? You have to be committed.
The object storage
There's gotta
guys
be
are
a
developing
big-
their own stack.
There's got to be a monetary nugget there that you're chasing to go invest that work, and that takes time, takes investment.
I guess the question really becomes, what's the difference in cost per capacity for SMR versus CMR? If it's significant, then there's going to be a much higher adoption.
Well, you can see in our drive tech, the ones we're sampling today, we have an 18 terabyte CMR, a 20 terabyte SMR. We expect that delta to get wider and wider over time. We've been very public about positioning that. Okay.
So that's capacity per drive, but it doesn't tell me the cost function.
No, it doesn't.
Okay.
There's an opportunity for us and our customers to benefit from that. So we are the industry leader for capacity enterprise hard disk drives. I think unquestioned leader in capacity enterprise drives. The 14 terabyte drive is the predominant capacity point today. We have over 80% of the sales in 14 terabyte is Western Digital. We have 56% of the exabyte shipped, 50% of the units shipped. This is data from calendar Q3 last year. It was reported in November based on our data and public data that was reported. We also have, as I mentioned, capacity enterprise is not just about one capacity point. Our 10 terabyte air-based product. This has a tremendous amount of innovation in it. This is not Helium. This is an air drive, which has compelling cost advantages. It's a 6-platter. It's the highest capacity or the highest density commercially available air drive today as well. So we're excited about products we're bringing to market the first half of this year. We're sampling now. We announced we were sampling to multiple customers before the holidays. We're now in qualification. We expect to ramp into production the first half of this year our 18 and 20 terabyte drives. This also has a 16 terabyte node to it as well. So it's a very efficient 9-disk platform. It is the very first drive in the industry to implement energy assist technologies that's commercially available, and we're very, very proud and pleased with our opportunity with this product going forward. It's going to advance the market.
You're going to talk about energy assist later?
Yes.
Okay.
So my last slide, I just want to circle back on this TCO equation because it's easy to think about 4 or 5 racks and you say, okay, 22% smaller rack space, but think about it at zettabyte scale. The world has a challenge, in terms of how to store all this data. We're storing about 10% of the data created today. So if you think about that future data point with 103 zettabytes, maybe that's about 12 zettabytes stored. So you think about a zettabyte of storage. If you think about a 14 to an 18 terabyte drive, that's up to 25 million fewer drives required to hold a zettabyte, up to 42,000 racks savings, and saving enough power to power over 500,000 homes for a year. So more data will be created, and we're up for the challenge of storing it. But some of these technologies are not just about dollars per terabyte. It's actually about making a pretty big difference in terms of the efficiency with which the world's going to store data going forward. Okay.
So, quick question on the failure comparison, failure rates between the helium and the air drives. Are they like for like, or with the helium, is it coming out better because of its?
In general, we designed to an enterprise reliability requirement, which is north of 2 million hour MTBF. Helium definitely has advantages in that area, but a lot of the fundamental things around drive reliability are pretty similar between the two. So,
I'm just thinking now that you've got probably years of statistics coming back.
Oh, yeah. Yeah, yeah, yeah.